Okay, so we're going to talk a little bit about negative exponents. And when we talk about negative exponents, something special happens. And I'm just going to go ahead and do one the way we would have done in Developmental Math 1, and that is just to multiply it out. So in the numerator, we see 10 squared, so that's 10 times 10. And in the denominator, we have 10 cubed, so that's 10 times 10 times 10. And then we also know that when we are simplifying fractions, we cancel out the stuff that's the same, the top and bottom. If everything cancels out in the numerator, remember we need to put that 1 in there. So that's 1/10. Now let's go ahead and do that same problem using the exponent rule. And that tells us that when we are dividing, we subtract the exponents. So that's actually 10 to the negative 1. So what this tells us, using two different methods that are both perfectly legal, these things are equal to each other. So the rule that we want to get comfortable with, or the idea that we want to get comfortable with, is when we see a negative exponent, we put the base with exponent into its reciprocal position. And change the sign on the exponent to positive. All right, so this is our basic rule of thumb when we're dealing with negative exponents. And it does take a little bit of practice, but let's go ahead and look at this one. Now this has 3 to the negative 1. So the negative 1 tells us we put it into its reciprocal position, so we put over into the denominator, into the, we've still got the 1 power, it's now positive, and we simplify it. Same thing happens here. We've got 4 to the negative 2, so we put 1 over 4 squared, so we put the 4 into the denominator. It was in the numerator, now it's in the denominator. And then we simplify it, because 1 over 4 squared isn't particularly pretty, so we're going to do 4 squared is 16, so that really simplifies to 1 over 16. Now let's go ahead and take a look at this one, and I'm going to rewrite it to do 5 to the 1 times x to the negative 3, because remember, if we don't see an exponent, we know that it's a positive 1. So when we look at the negative exponent, we have to remember that this is what has the negative exponent. This we need to leave alone. It's got a positive exponent. So that 5 stays in the numerator, but this goes to the denominator, and of course we drop that negative, and that is simplified, the simplified form. Now we've got something that's a little bit more complex. So we remember at each term separately. So here we've got 4 to the negative 2, so that's 1 over 4 squared, plus, and then we've got 2 to the negative 3, so that's 1 over 2 cubed. We simplify those, 1 over 16 plus 1/8. And now we have to actually add these, and that means we have to go back to our addition rules where we need to get an LCD. The LCD is obviously 16. So I'm going to multiply this by 2. That means I have to multiply the numerator by 2. So that gives me 1/16 plus 2/16. Add the numerators, 1 plus 2 over 16. And you're done. Let's go ahead and take a look at this one. This one is different because the negative exponent is in the denominator, and that's okay. It doesn't matter. We put it where it's not. If it's in the denominator, that means we move it to the numerator. 4 cubed is 64. Same thing happens here. Here we've got 5 over, and that's 5 over 1. Excuse me, 5 to the positive 1 over x to the negative 3. So again, 5 to the positive 1, that's going to stay in the numerator. The x to the third is going to move to where it's not, so it's going to move up to the numerator. So we have 5x cubed. This is going to take some practice. Now, this is one where we could do a couple different things, but I'm going to use the division rule. And the division rule says that when you have like bases and you subtract them, and you're dividing them, you subtract the exponents. So we have -7 minus, and the denominator is -4. So you've got to be really careful. And remember that negative gives you positive. So now you've got x to the -7 plus 4, which is equal to x to the -3. It's in the numerator with a negative exponent, so it goes to the denominator and has a positive exponent. Same thing here. We've got a y. So we have a like base that we're dividing, so we subtract the exponents. We have -6 minus, denominator is a -9. So we have y -6 plus 9, which is equal to y to the third. Now let's try this one. So we've got x, again, we're looking for like bases, so x to the 14th over y to the 35th. We look at this, and the first thing that you have to do is say there's nothing I can do because I don't have like bases. So you've always got to be paying attention to the base. Don't let it trick you. Now the next one is sort of similar, except you see that you've got the negative exponents. So when you've got the negative exponents, remember that's going to go to the denominator. Oops, and that's going to go to the numerator. So this is going to be y to the 35th and x to the 14th. This little guy here, this is saying we're going to multiply these. So we've got y to the -35th. And again, we're going to multiply what's in the exponent there. So y to the -14. And now again, we're going to do a little, make them positive by putting them into their reciprocal position. I just changed something there, didn't I? Sorry, x. There you go. So you've got sort of different versions of the same thing that could happen. All right, so let's go ahead and look at this one. Oops, sorry. Here we go. So we've got a few things that we can see here. We've got a 5 to the -1. So that's going to go into the denominator. And now we've got some x's here. So we've got x to the -4 minus -9, or raised to the -4 minus -9. And then we're going to go to the y. So the y is 3 minus -5. And then we've got a z, which is -3 minus -3. And now we simplify all these, so we keep the 1 to the over 5, and then x, remember this is a plus, so we've got -4 plus 9. Again, this is a plus, so we've got y, 3 plus 5, again with the plus. So we've got z, -3 plus 3. So now again, we've still got the 1/5 we're carrying with us. We've got x, combine this, we get a 5, a y to the 8th, and a z to the 0. Well, remember, z to the 0 is 1. So we've got the 5 in the denominator, x to the 5th, and y to the 8th in the numerator, and times 1, so of course that's done. So that's all there is to that one. Okay, so we're just going to do something that's a little bit more complex. And remember, whenever we see these things, the first instinct should be, to simplify what's inside first. Remember, we're always thinking order of operations. So we're going to simplify the numbers. Then we're going to look at the x's. Then we're going to look at the y's. And then we'll deal with what's out here, that extra exponent outside the parentheses. So we've got 3 to the 1 to the negative 1. Well, that's going to go to the denominator. The 5 stays in the denominator. And then we've got x, negative 2 minus negative 7. We've got y, negative 3 minus 2. I'm keeping the negative 3 here. So now we've got 1 over 15. Don't forget that that's adding. So we've got x, and that's going to be a negative 2 plus 7 is positive 5. And then we've got a y, negative 3 minus 2 is negative 5. Now we're going to make that look a little nicer. So we're going to go ahead and write x to the 5th, y to the negative 5, 15. I'm going to put a 1 there, and then to the negative 3. Okay, so the inside of the parentheses is as simplified as it can be. Now we're going to go ahead and use that power to power rule. And of course, the power to power rule says that we just multiply 5 times negative 3. Y is negative 5 times negative 3. And then in the denominator, we've got 15, 1 times negative 3. And now we're just going to do that. So we've got x to the negative 15, y to the positive 15, and this is going to be 15 to the negative 3. So now that we've got everything as simplified as it can be, we're going to put anything that has a negative exponent into its reciprocal position. So 15 cubed in the numerator, y to the 15th and stays in the numerator, and then this x to the negative 15 is going to go down to the denominator. And then this 15 cubed, I'm not going to tell you that you have to do that math. I just want you to see what happens with the signs at this point.